My name is Joanne Heraty. I'm an assistant specialist and I manage the field and lab operations for Dr. Valerie Evener at UC Davis. And today we're up at Sierra Foothill Research and Extension Center doing a final end of season sampling on one of our primary experiments where we're looking at how grazing impacts seedling thinning dynamics in California grasslands. What we're really trying to understand is how to better assist rangeland management decisions and how to maximize forage production. So essentially the main driver of our research up here is to really tease and understand the two central mysteries of California grasslands. The first is that year-to-year and site-to-site variation don't seem to really be well explained by the typical benchmarks that we're used to seeing in California grasslands. And that is things like climate and soil type and residual dry matter. And that second, plants throughout the growing season seem to be getting a lot more nitrogen than is typically seen in the sources that we're used to using, like litter decomposition, nitrogen deposition, nitrogen fixation, and soil organic matter turnover. So we really want to understand these dynamics, and as it turns out, both of those mysteries can really be explained by one unique mechanism in California grasslands, and that is high seed production as well as this high self-thinning of seedlings throughout the growing season. So a lot of the nitrogen at the end of the season is typically found in the seeds more than anywhere else. They'll all germinate with the growing season and when the rains come. And then there'll be this, about 50 to 90% of them will die off throughout the growing season. And they'll die off along at the same rate as when there's this peak competition happening with the plants. So what this die-off leads to is sort of this ultimate slow-release fertilizer in the system. So in order to sort of monitor that seedling thinning dynamic and understand how grazing plays a role in that, we have these paired grazed and control site throughout SFREC around the field station. And beginning at the beginning of the growing season with the rains, we start monitoring about every 6 to 8 weeks several different measures within these grazed and ungrazed plots. To look at above ground biomass, we take a measurement of the number of seedlings. We manually count the number of seedlings, the number of forbs, and we sort out the litter from a sample of this, what's called a seedling core at each harvest point. We, at the end of the season, we take a large portion of end of season litter and make these litter bags. And we'll deploy them out at the beginning of the growing season and collect them at each time point to get a measure of the percent of litter decomposition rate that's happening throughout this season. We also take a root core using a twist auger to a depth of 15 centimeters for a measure of below ground biomass. And we use these really cool PRS probes here. It's a paired cation and anion probe to get a measure of the total nutrient profile available to the plants throughout the growing season. So we do that roughly every 6 to 8 weeks. And what we're really trying to understand here is how we're trying to track the seasonal variation of nitrogen supply over space and time, and how it really relates to this rates of seedling thinning in plants in California grasslands.